Hello everybody, I'm Mitchell Augustin, and today I just wanted to do a second video on Aurora v4 that kind of goes more in depth into what's actually going on in the back end of the v4 server. In the other video that I did, I just kind of showed some of the types of responses that Aurora could return and demonstrated how she could generate sentences dynamically from the content that she's provided in a certain group chat. Uh, but I really wanted to show what's actually going on in the background here, just to explore the types of processes that are, just to kind of demonstrate the types of methods that are used to calculate an appropriate response to a certain query. So I'm going to start out with a very simple query, which is just Mitchell writes code. And I'll go ahead and submit that. And I've got my logger output right here too, so that's actually showing what's going on in the server. So it's just doing some update statements right now, modifying the database to show that that has been said. And as you can see, she returns a response node that says correct. That's just what she would say in the chat, saying that she agrees with it. But down here, this is what I kind of wanted to show in this video more. This is some of the metadata she responds with that she uses to figure out the meaning of a certain sentence. So as you can see here, the given subject in this sentence is Mitchell, but the subject that she actually got from that is Mitchell Augustin, which she does by knowing that Mitchell is just like the short form first name for Mitchell Augustin. And I'll go into where that comes from in a few minutes. There were no sentence subject modifiers, and no sentence object modifiers either, because I just said writes code. I didn't say like writes good code or anything. So it's a pretty basic sentence, but I'm actually going to go back and try it out by saying Mitchell writes good code, and that'll go and calculate. And I actually want to, I'm going to pause this output log here, because I want to show, I'm using a part of speech tagger, I believe it's the Stanford POS tagger, and it gets the part of speech for everything in the sentence. And after that point, my program hops in and actually uses that to help figure out what's going on. Aside from this Wolfram Alpha and Weather Underground, I'm not really using any third-party programs in Aurora. It's almost entirely my code. It is entirely my code with regard to the natural language processing and the artificial intelligence components, if you will. And it seems to be working pretty well so far. But anyway, what's going on here is she breaks it down into each individual word, gets each part of speech for it, and then the program figures out what the subject is, which is Mitchell, actual subject is Mitchell Augustin, and I kind of explained that a minute ago. But anyway, as you can see here, there's also an object modifier, which is good. And down here, it gives some positivity info for the word good. Now, good has a positivity of 1. I'll explain what that means in a minute. But as you can see, she just gives another statement of agreement with that. Actually, I want to go ahead and explain what the positivity values are determined by right now. So if I go and open up Aurora's main database here, there's a bunch of different databases that I have connected to Aurora, but this is kind of the central one, if you will. It's the context-inclusive database. So everything that's said to Aurora, all of Aurora's opinions, if you want to call them that, are stored here under mainly the dictionary positivity. I'll just go through these. So dictionary positivity is the primary positivity dictionary, as the name suggests. And this just contains a bunch of different words from the English language, currently almost 2,000 words, and positivity values that are either positive or negative depending on what Aurora thinks of that word. Now, to start out, I just hard-coded a bunch of basic words like good and bad or okay or, all of these pretty common words from the English language. But after I got probably about 50 or so of those written in, I actually wrote Aurora's program to allow her to calculate a positivity value based on their relationship with some of the predefined words. So since I put in the initial 50 or 100 or so words, I don't remember how many there were to begin with because it's been a long time since I did that. Uh, I've just had her running and interpreting different words, and as you can see, like despise, that was not one that I put in manually. She calculated that to be -3. Um, let's see, we got malevolent. I think I saw that. I thought I saw malevolent. I don't know. Maybe it wasn't. Uh, but it's got a bunch of those in there, and she calculates those based off of if they have if they're synonymous with good or bad, or if their definitions contain any words that are synonymous with any of the predefined positivity values, and a couple of other factors, but I won't go into too much detail there because it's just mainly low-level stuff. But anyway, that's kind of the core of Aurora's opinion system and how she determines whether or not she's going to respond with a statement of agreement or a statement of disagreement. So I'm going to go ahead and go into the opinions positivity tab because this has some more opinions. So I'm just going to go to Mitchell and type that wrong. As you can see, there's some duplicates here, quite a few duplicates. That's just due to a bit of an issue that I have. Sometimes it just creates double entries, but they don't really matter because all she's looking for is the either highest or lowest. But as you can see, she currently has a positivity value of 27 for me, which is pretty good. That means she likes me. And that's because mainly a lot of the test queries that I use are really basic stuff like Mitchell is good or something when I was programming it initially. And she also takes it from things like Mitchell writes good code. She sees that as a positive thing, as you can see from this, and attributes that to my value in her database. So if I asked her something like basic, like is Mitchell good, she should respond just saying yes, or something along the lines of that. And yeah, she says, as far as I acknowledge, Mitchell Augustin is good. Oh, actually, that's another thing that I wanted to go through, the synonym generator. So in order to vary her sentence patterns a little bit, since sometimes they can get a bit sort of template-like, I added a feature that allows her to search the internet for synonyms of a word. So she just does this through Wolfram Alpha, and I do use another third-party library called WordNick that's just a dictionary. But anyway, she just searched for synonyms of no, because the original pattern was as far as I know, and she found acknowledge, which it's close enough. And I do have a way to edit some of those out. Sometimes she says things that just don't make much sense, and I can remove those synonyms if necessary. But anyway, that's how some of the basic queries are interpreted. Now, as you can see, there's quite a bit of logger output because she goes through a couple hundred different methods through probably 30 to 50 different class files for any given query because there is a hefty amount of stuff going on in the backend here. So with these basic queries, there's a lot of output, but there's some more output from some of the more advanced queries like the subquery generation that I explained earlier on. But I actually kind of want to go through and show what the database looks like for that. So I've got right here, I've got my server open, and as you can see, these are all of the databases. They're just SQL databases that Aurora's file system is made up of. So this context right here is the context for the group chat that Aurora is in primarily. That's the one with, I said, like 10 or so people in it. And this is my user ID in the group chat, so she just knows that if I say, like, I am doing something, it'll translate that to Mitchell is doing something. But anyway, I'm going to go ahead and open up this database, which is the subject info. Maybe I already opened it? Let's see. Oh, there we go. So this is where the subquery interpretation comes in. And bear with me, because subquery interpretation gets a little bit complex. So I'm just going to search for me in the subject, so it's limited to stuff that I say. And I'm going to test it out with... Actually, I'm going to close this. I want to test it out with the query Mitchell thinks Aurora is... I'm trying to think of a good query to really demonstrate how this works clearly. I think I'll say... Mitchell thinks Aurora likes technology. And it's going to go through, and it's going to calculate all of that. It might take a little bit longer because this is a more complex query than just like Mitchell is good or Aurora is good or stuff like that. Looks like she's trying to... Oh, this is another thing she can do too. If she sees a query, that contains words that she's not familiar with the other... Actually, I'm going to come back to that. So anyway, she just went through and calculated that. But what I really want to show here are the reference IDs and how she references different subqueries. So I'm going to go ahead and open up that other database that I had open a minute ago. So this is the main subject info database. So if I go to this one and I search for thinks, here we go. All right, this is the one that I just, this is for the query that I just put in. So the query is in here, it's just stored as Mitchell thinks and then this reference ID. So if I go to this other database right here, the reference database is what it's called, and I go right back to that same reference ID, which is 4144, it's got the other half of that query, which is Aurora likes technology. And this is kind of how I demonstrated the other one. So if I were to ask, like, does Aurora like technology, she would search through all of her reference databases and find this query in the reference DB and realize that, okay, that's not the full query. I need to return the other part of it too. Find its previous reference, which is located in here, and return the full query, which is Mitchell thinks Aurora likes technology. So it's kind of complex, but it works pretty well so far. And it comes up enough to where I think it was a good implementation, and it kind of allows her responses to be a little bit more dynamic, and it allows her to understand things that don't have to be like one-on-one related to like a query response pair. But anyway, as you can see, it also saves all of that data. For example, if I were to say like Aurora likes good technology, it would have saved good here in the object modifiers thing. And since there's not a next reference, that's just the end of it. it just has no reference. So back to the context-inclusive database. There's a couple of other things that Aurora has in here. One of them is the predicate nouns database. So I'm just going to go back to myself. I'm going to ask a basic query. I use this one to test a lot just because you always get like the same answer since it's really basic. Am I a programmer? And when I ask that, it'll go through and calculate. And this is kind of an example with this first part of the response. This is one of the issues I was talking about earlier on when I said sometimes she responds with a synonym that isn't really an appropriate synonym. So she said, as far as I live. I don't think that's correct. So if I want to go back and tell her not to use that as a synonym, I can actually go straight into this experimental database, into the synonyms. No and live, valid should be set to false. So now she won't use that as a synonym for no anymore. Unfortunately, doing that manually is really the only way that I know how to right now, but I'm looking into kind of getting a more effective way of actually getting some of these synonyms to be more accurate. But you can see she did return the response correctly for the most part. Mitchell Augustin is a programmer. And that comes from this database, which is her context-inclusive predicate nouns database. As you can see, she's got Mitchell Augustin and programmer here. And she's also got good as an object modifier, because if I were to ask if I was a good programmer, she would be able to respond yes with that, or something along the lines of it. So far, I've just kind of gone over some of the template-based responses is what I kind of call them, because they're more formulaic than anything. But one of the other things that's a more recent feature of Aurora is the experimental database, which right over here, I'll go ahead and open it, contains a lot of the more dynamic stuff, like that represents a lot of the colloquial language patterns that I was referring to with the group. So this is kind of where her language patterns come from. So if I go to type statement, this is just what it's got here is a list of all of these different parts of speech and what part of speech is logically going to come next after it and the number of times they've been used. So if we go here, we can see that this is what she's generating all of her queries from, essentially. She'll take the starting part of speech and figure out what comes after it. So for example, and this just comes from, let me clarify, this comes from like the part of speech generation in all of these different sentences. So for example, the sentence that I just said, which was, what was it? Am I a programmer? It may not be saved here. Well, am I a programmer? It would take the parts of speech for each of those words and then stitch it together and store it in this database and tick up the uses value. So then when she goes to generate a sentence, she figures out what the most logical next part of speech would be. As you can see, she determined that this would be an effective sentence. And she forms her sentence using words that are appropriate, such as far as I know, Mitchell Augustin is a programmer. As far as well, in this case it said live, which isn't correct, but you get the idea. Mitchell Augustin is a programmer. So that's kind of what's going on there, and that's how she generates her sentence patterns more dynamically than other artificial intelligences. And then questions. I have a different version of or different database table for each query type, just so that since questions and statements have a different form in the English language, uh, just so that there's no confusion as to what format it should be put in, because it wouldn't make a whole lot of sense if Aurora answered in the form of a question for that. But anyway, that's just one part of this. And then I already showed the synonyms database. She just stores some synonyms there. The phrases database is another thing that's a newer thing. This just has words that are used in common and stitched together. So a lot of these, this hasn't served as much of a purpose as I initially intended it to, because it doesn't, for some reason the system just doesn't pick up on it very well, and they don't, the uses don't tick up a lot. But as you can see, there's some phrases in here, like computer programmer has been used a few times, or DM me is one of them that's used a lot, and that got picked up, or an emulator. Just basic things that are often used right next to each other. One of the bigger things, though, too, is the query response thing, or the query response generator. So if I type lol here, you can see this is one that I think I showed it in the slideshow in the last video. Lol and funny meme are associated with each other. So since that has been used a few times before, generally when someone says lol, Aurora will respond with funny meme or something that is linked in the synonyms table. So that's kind of how she gets some of her responses that are just more mimicking the group. And this table, that's what this table is primarily used for. As you can see, a lot of these, once you scroll down, just have a single use, and that's kind of how I'm trying to filter out things that are always said right after each other. Like, the biggest one is ping pong. Well, it's actually backwards here. Ping comes first and then pong comes second, and that's been used quite a bit, just because it's a very frequent thing. And that's one where the response to ping should always be pong. So naturally, that one is saved as basically a static response at this point, because it's been used so many times. And there's some other ones that are like that too. My internet just died, and RIP. That's pretty common. These don't have to be the exact thing either. Like, you don't have to say this word for word, letter for letter. It actually uses the same synonym generation method that I explained earlier, as well as a Levenstein distance program, that as long as it's within 85% lexically accurate to the saved query, it'll return this response and tick up that uses value. So that's kind of how that works out. I just thought I'd mention that because it's kind of a big part of Aurora's more recent update. Let's see, what else is there to show? Oh, the names. One of the things that I mentioned earlier is Aurora can translate nicknames like, well, first names like Mitchell into full names. That's all stored in this database right here. So right here, you can see this is that table where that came from, and it saves nicknames based off of also what is said in the group. Some of these are hard coded just because I needed to test stuff out. But as you can see here, it's got Mitchell is Mitchell Augustin. And what happens there is, in addition to the members of the actual group chat, it can also save names dynamically. So, for example, Bill Gates is one of them that's saved. So if you say a full name in the chat, it's going to interpret that first name as the first name that should be used to reference the full name. So if I were to say, let's assume that this data value wasn't in here at all. If I said Bill Gates is an amazing programmer before Aurora knew anything about Bill Gates' existence, she would read that Bill Gates is a name and save it with this exact value. And that's actually precisely what happened here, because I use similar queries to that all the time to test it out. So she can just save names dynamically like that, and then whenever a query is said with just the first name, since people don't usually use full names in conversation like that, it just saves it, or it translates it to the full name. And it can go vice versa too. If you said the full name, well, it would automatically pick it up, but you could also ask for like the nickname or something of Bill Gates, and it would just say Bill. And then the Discord ID is just used for whenever someone uses a first-person pronoun like I or me. It just replaces it with whatever their user ID is, or their full name. So that's that. So anyway, that's most of what I wanted to cover today, just a little introduction to the back end of Aurora v4. I could probably go on for a lot longer about some of the less interesting stuff going on in the back end, but I doubt that most of the people watching this would actually be interested in hearing that. But if anyone is, feel free to leave a comment, and maybe I could make another video explaining how some of the lower level stuff works. One other thing I don't think I mentioned explicitly is Aurora v4 is it runs on Tomcat, or on a Tomcat server, so it's entirely written in Java, which is the language that I'm most familiar with, and it's got somewhere around 50 class files worth of code that I wrote, and I'm not really one for measuring programming ability in terms of number of lines of code written, but there's probably at least 10 or 20,000, if not more, lines of code that I've written throughout this entire project, and I intend to just continue to raise that number as I add more features to Aurora. The next big thing that I'm going to be working on is really boosting her ability to hold a coherent conversation. Right now, a lot of her responses have improved drastically since I first started developing Aurora v4, and now that her responses are more human per se, I think I'm going to be able to move into the area of actually getting conversational continuation, is what I'm calling it, to be more feasible in the future, and hopefully that'll allow her to be a little bit more effective than some of the existing AI chatbots. But anyway, I guess that's all for this video. I hope you all enjoyed watching, and thank you again. That's all.